Right, so as mentioned, probably a pretty good day to be here because the radius is going to get a little bit more complicated to figure out. So right here, I stuck with the same graph that we've seen quite a bit with the y equals x squared and y equals the square root of x. Again, which one's which? Which one's the one on the bottom here? Yeah, that's y equals x squared. And then the top one, maybe we'll go this way, is y equals the square root of x, right? And now the problem is well, lately we've been just revolving that around the x-axis, which would be Washer method because there'd be a big R and a little r. I believe big R was the square root of x, little r was x squared, and we squared them separately is about all you had to do. You took big R squared minus little r squared, throw the pi out front, and you're pretty much done with it. Well, now we're revolving it around the line y equals 2, which is unfortunately up here. And again, that's when I do that little symbol, so I remember. Again, that's kind of just mine. That's not necessarily something you'll see anywhere else. So I remember where I'm revolving it around. Now remember, the y value of the function determines that distance. This is what the y value of the function figures out. So is that distance right there I just drew in green, is that the radius of this thing then? No, the radius of this thing's actually kind of going the other way, is the radius of this. And if you want a visual, I think I got one in there. That's what just one of them is going to look like. So big R in this case, again, it's the one furthest from the axis of revolution. So which one, y equals x squared or y equals the square root of x, which one is actually further from the axis of revolution? Okay. Yeah, x squared, do you see how that's actually further? To get all the way from here all the way down to there takes a lot more work than just getting to there. Okay. So again, big R and little r, I told you already that that's probably going to be the hardest thing to figure out. And you know what, if you can figure out this one and kind of see where it's coming from, I think you're going to be all right. There's a lot of ways you could look at it. I tend to look at it this way. That 2 is basically the distance from here all the way down, correct? It would be 2. And is it always 2 as I go from left to right in this problem? Yeah, it's always going to be 2, the distance all the way down to the x-axis, right? So what I really want to do to get big R is get rid of that. Two minus x squared, you got it. Because this distance here, if you integrate it, is what you would get if you integrated x squared, right? And I want pretty much everything else. So if I take 2, which is all of that, and subtract that little bit out, does that give me what big R is in this problem? It does. Now how about the other one, though? Again, 2 is all the way down. What I want to subtract out this time is that much. Somebody said it. 2 minus the square root of x. If you can figure out those two things, you're set. But we need to stop right now and make sure you see why. Yes?
Wouldn't you subtract, like, from 2 down to square root of x? Because that's the washer, there's no airplay.
Okay, here's the question, and that's exactly where people get messed up. What Taylor is thinking is, aren't we supposed to subtract out this inside one? And that's exactly what we're doing. We're just trying to find little r right now. The formula is going to subtract that volume for us. We're just going to try and find out what y value would figure out little r for us. And what we then have to do is say, well, which one's closer to the axis of revolution? Well, it's most definitely that function is closer to the axis of revolution, correct? And we just need to figure out that distance. The y value of the function is right there. And so we're basically saying, well, there's the y value of the function. What's all the way down is 2. If I subtract those 2 out, it will just give me little r. Okay? But remember, we have to go in and square big R and little r separately in our formula for Washer method. And that's where this can definitely get complicated. Yes?
We're doing Washer method.
Yes, Washer method. Yep. Right, we're doing Washer method, which if we did this, it would create, it's very hard to see what these would look like, but kind of a really oblong donut, I guess, is what this would look like if I did this entire region and revolved it around. Okay. So here we go, volume, pi. You don't have to put pi out front if you don't want to. From where to where? 0 to 1. That's because these are, if I did put a rectangle in here, it would be dx, correct? And so we have to go from 0 to 1. So now you put big R in, which is,
Minus.
and I have to square it, minus little r square dx. Yeah, like I told you, once you figure out big R and little r, it really isn't that bad. But by no means was figuring out those two things easy. I'm not going to tell you that. And I think most definitely, I would suggest that you go with your calculator now, get this graphed, or you can clean it up. If you want to do it by hand, you'd have to FOIL and FOIL, combine, then integrate. It could be done by hand. It just takes a while. But I would like you to actually use the graphing calculators, if you've got them, to figure out the answer to this one. While you do that, I will pause it. All right, I know a lot of you are using the graph, which is fine, but I just want to review that other method that you have in case you do get stuck on these. And where else can you go if you don't want to use the graph on some of these? Math, yep. And down here is right there. And then you would probably start with a parenthesis, and it would be, what, 2 minus x squared. What do I have to type next? Squared, very good. And then minus, we start another parenthesis. 2 minus the square root of x.
Another parenthesis.
Ah, very good. This parenthesis I just typed just closes off the square root. Another parenthesis would close off the other one. And now you got to square that again. Now who remembers what comes next?
Yes.
Comma. X. Comma. Whoa. I don't know. Did I actually hit it twice? I didn't think. Now, is this going to give me the final answer? No, why does this not give me the final answer? Got to take it times pi, very good. And why is there pi in there again? Because the area of the circle is pi r squared times how wide each one of those is basically why that works out that way. And the reason we square them separately is because we are trying to find a volume here, and so we are trying to subtract that out. And I believe this is what some of you were talking about the 631 towards the end gets a little suspicious. And so what you can do on some of these, if it doesn't say to get it exact, just go ahead and multiply it by pi. And normally on the AP, 4 decimals is fine, so let's just go ahead and take it times pi. And the biggest thing is to show your work on there so they can see what you were thinking. Just actually write out the integral. Yeah, it's fine that you go to your calculator to do it. Write out the integral you did. There's normally points for that. If a problem's worth 9 points, there's a point for doing that. There's a point for showing where the answer came from, and so forth and so on. So the points get evened out fairly well. So if I were to round, it'd be what, 3.2463, and it'd be units cubed if you had to write something like that. You could probably do that too. The question was, could you leave it as 1.03333 pi? You could do that, but a lot of times I would just maybe write that out, say it's 1.0333 pi, and then actually put the other one too, just to be safe. Don't give the person that's correcting it, don't give them a reason to take points away. You got to realize they see a lot of these. So, any questions on that? All right. Well, let's take a look at. So we're doing the same graph. Let's see how we're doing on time. Pretty good. Going to do the same graph, but now we're revolving around y equals -1. Now I would still consider that the rectangle should probably go that way, which makes it a dx problem, which means we already know before we do a whole lot of work that it's going to be a pi here and from 0 to 1 again, correct? But going back to what I've been telling you, these two are the most difficult things to figure out. So let's get this out of here. Again, that's what just one of them would look like. So what is big R? I mean, big R is basically going from here all the way up to there, correct? Yes. Okay. Because which graph is this again? This top one is the square root of x, right? The square root of x, if you just said square root of x, you're telling me That's how much it is. If you just say square root of x, is that what big R is? No, it's that much plus 1 more. Is that always going to be the case? If I did it over here, is it that square root of x and then plus 1? Exactly, that's what it is. It's the square root of x. And then make sure that the plus 1's on the outside. And in fact, what some people do on this one is they just write 1 plus the square root of x to make sure you know the 1's not inside the radical. Okay. So now little r, again, you got to figure out which one's closest to the axis and which one's furthest. Well, I think we can all agree that this one's much closer to the axis of revolution, and that's y equals x squared. But that right there is if you just use the function. That's not our radius. It's that plus 1 more. Okay. Any questions on that? Because if you're understanding these two, you're doing great. Okay, everybody good with that? Now remember, we are squaring them separately though, so why don't you go ahead and let's plug this in here. Big R, square root of x, again, plus 1, make sure you separate that, squared. Plus or minus goes in between. Why minus? Why does a minus go here? Because they said so? Yeah, you're subtracting basically the volume of the whole. Okay, so you subtract the volume of the whole, which is x squared plus 1 squared dx. Once again, why don't you take some time to try and get that answer on your calculator. Well, let's see how you did here. Again, we'll go to the calculator. So again, if you don't want to do the graphing one, because sometimes that's a lot to type in with that graph. And there we go, square root of x. I keep looking at the wrong one. Plus 1. Oops. Squared minus x squared plus 1. Squared. Again, comma x, comma, is it still 0 to 1? Yep. Once again, that's not, it's going to be very similar to our last answer because I asked you if you thought this was going to be a similar shape, and it is. It's very close to the same size, but that's not the answer because we still have to go times 5.
We just put 0.96675.
Probably if you show your work, yeah. You can just put 0.96675. Yeah. But again, don't give them a reason to mark it wrong. Okay,